In this video, I want to use the assembly that we've created to do some analysis on our catapult before we cut any wood or make any physical prototypes. So to do that, I want to analyze, at least initially, the angle, the max and min angle that I can rotate my this device, which we call the launch beam. So to do that, let's turn off visibility of this column, look at it from the front view, and we can do some analysis here. Let's zoom up. And so if our design includes having rubber bands that are stretched in this region over here on the front of the catapult, and so here the rubber bands are slack, so we might have a hook here and down here, and then we pull back and stretch the rubber bands here, creating elastic energy that we can release later to shoot the ball. We're going to want to know the maximum angle that we can pull that back. And as you can see with this design here, we're going to hit the stopper. So this design looks to be not ideal for that type of catapult, but let's get the data. So we're going to zoom up, and we just want to get, somewhat close. So right there, what I'm looking at is the stopper hitting the launch beam, and that's going to define an angle. Let's call that the back angle. And what we can do here is we can come down here to the measurement details, click here, and then we can click on this line here on the launch beam, and let's say a horizontal line. Any horizontal line I think will do. But let's just pick this one right here. And so here it looks, and if we come over here to the measurement results, we can hover over the angle and we can see what angle that is. And so that angle is 10.187 degrees with respect to the horizontal. So that's good to know. We would like probably with that design to pull it back all the way to here, in which case we have a different angle. Say we're all here and we've got it stretched here, and you can see we've got a larger angle here, 136 degrees. So 17 degrees there, and so it looks like OnShape produces a positive angle no matter what, which is something we'll have to deal with. So okay, so this is quote unquote the pulling it back and cocking it. So let's call that the back angle. So that's 16 point, let's just say 17 degrees, and so we'll write that down, record that. And what we can also do is continue hovering over there, and I can, on a Windows book, you can hit print screen on the keyboard, and then you can go and you can record that data. A new slide, Control V, and now I've got that data. So capture that using the print screen feature of your Windows or Chromebook. And now we can come here and determine where it's going to, once it gets going, it's going to eventually hit the stopper and release the ball. In this particular case, you can see that it would hit right here. So you can see we've got a 74 degrees here. So we'll write that down, and then we'll print screen right there. Come over here, make that smaller. So we're going to come down there, and we can see that we've got that. So this is the sort of the extreme configurations of the catapult as we've designed it here. So that, I don't know, that's going to require some analysis to see if we can use it with a stopper in that location. But the great thing about CAD, and one of the main reasons we look at CAD, is that we can learn that, and now we can move this guy. So that's the thing we're going to move. So I'm going to put the column visibility back on so I can see what's going on. And now let's go to the other extreme. Let's move the stopper over here, and that's going to change things. So what I can do to find where the mate is for the stopper here, I can come over here and right click on one of the mates and say show all mates, and that's going to show me all the mates. You can see I have a revolute mate here, and I have a fastened mate everywhere else. So that's the one right here. And which one is that? It looks like it's fastened 1. Is that right? I guess it is. So let me go ahead and suppress that one, and that should mean that I can move this guy around, which I can. So let's now put it over over here, and I'm going to apply a fastened mate there and there. Okay, I'll take that. And now I've changed the configuration of my assembly and the whole problem I've got here, so I'm going to hide all mates. They kind of get in the way. And now I can do some more analysis like I just did before. And I'm going to hide the column, hit front so I can see what's going on. Okay, now when it's there, I can pull, wow, I can pull that all the way back. So in my current configuration, I'm not going to interact with the stopper bar at all when I pull it back. Remember, the idea here is we've got a hook here and a hook down here, and we're stretching the rubber band in this area. So what I need to do now is turn off visibility of some of those column supports. There we go. And you can see that I can go all the way back until I touch the bottom, or the base. So that's significantly different. Okay, that's good. So let me go back to the show measurements, and I'm going to go from here to here, and that is 53 degrees. And so let's see, so I'm going to print screen like that, come over to get rid of that pretty easily, and now that's as far as I can go back, 53 degrees with respect to here. So we'll record that number. And now let's see, once it releases, it goes kind of, oh, but it hits really close right here on the stopper bar. So it looks like our ball is going to go almost straight up, but now we know that because we did the CAD on this. So let's find out what that angle is. Let's come up here, and from this angle to this angle, 13 degrees with respect to the horizontal. So it went from 50 something to 13, and so that's good to know. So let me print screen again. We'll come back here, come out, and okay, we got it. Now it's becoming clear that neither one of those extremes are ideal for this catapult, assuming we're going to power it the way we had discussed. So let me come over here and suppress that mate, and now I can move this guy around. So I think what I'm going to do is put it right in the middle on top there. And so let me turn it around and put a fastened mate sort of, how about at the bottom? Let's see, let me zoom up right there and then right there. And if I turn on the visibility of the other column there, yeah, okay, so it's right there. Now, okay, this might be an intermediate situation, so I'm going to turn off the column. I do that, yep. So now when I pull it back, I'm going to hit, what am I going to hit first? Looks like the stopper bar, and let's measure that from here, that angle and that angle, any horizontal line, so that's 47 degrees. So shift print screen, come over here, new slide, control V, I know that. And of course now I want to see that how far it can go in the other direction, so it's going to come along here and boink, it's going to hit right there, as you can see. What I might also do in this bar, if I'm going to do it that way, is make this a diagonal edge so it's not hitting on the corner. That could tear up the launch bar. Let's go back and get that angle. So from there to any horizontal line, that's going to be 133 degrees. So the way Onshape is defining these angles is a little hard to wrap our minds around, but as long as we have these pictures, print screen, we can take a look at it. There is our other extreme. So based on this, it seems clear which design is the better one, and CAD has allowed us to determine what that is. And so this is the way you can do some analysis on how to design your part before ever making any physical parts whatsoever and committing money to the project. So hope that helps. Thanks for watching.